Water has a density of about 1 gram per cubic centimeter. If a pool in the shape of a perfect cylinder has a radius of 2 meters and a depth of 3 meters, what is the pressure at the bottom of the pool, assuming it is completely full of water with a density that is exactly 1 gram per cubic centimeter and that the atmospheric pressure above the pool is 101,325 Pascal? So I think this is something we can just apply the pressure as a function of depth formula to. So P is equal to P naught plus rho GH. And that density rho of 1 gram per cubic centimeter wound up being equal to 1,000 kilograms per meter cubed. We showed in an earlier example. So I'm just going to write that there to simplify things. P naught is given to me as 101,325 Pascal, but that's a Newton per meter squared, so I'll write that because that might simplify looking at the units. And of course, G is the familiar G that we know how to work with, hopefully. So let's go ahead and put the appropriate numbers in here. So we'll have 101,325 newtons per meter squared plus 1,000 kilograms per meter cubed times 9.81 meters per second squared times, and this is the one thing I forgot to write down. I have to go back and look at the problem. It says a depth of 3 meters, and we're talking about at the bottom, so I think that implies that that depth h is equal to 3 meters. So we'll multiply by that 3 meter there, and then I can put this expression without the units into my calculator. I think when you analyze all the units here, right, 2 of the meters are going to cancel against each other, so you'd have like a kilogram per meter second squared. But if I maybe multiply, I mean, it should be a kilogram, or should be a Newton, right? So if I maybe took kilogram meter per second squared, that's like mass times acceleration is a Newton, and then the meter cubed against the meter here would cancel and give me over a meter squared. So this checks out, and it should. The number my calculator reports for this is 130,755 newtons per meter squared. So that's the answer. We can go ahead and check it, and it looks like everything worked, except that here we rewrote that as pascals, which is appropriate. It's also okay to leave it this way, at least in my book it is.